All right, so I'm going to do chapter 2, number 14. Remember, you should do this again yourself and then come check the way I do it to make sure that it matches. But chapter 2, number 14 says that a jet plane is cruising at 300 meters per second when suddenly the pilot turns the engines up to full throttle. So I like to draw a picture to graphically understand what's going on here. So here's my airplane going along, and it starts out with an initial velocity of 300 meters per second. And then it suddenly turns up the engine, so that means it's accelerating. After traveling 4 kilometers, the jet is moving at a speed of 400 meters per second. So 4 kilometers later, the jet is now going 400 meters per second. So it accelerated. What is the jet's acceleration, assuming it to be a constant acceleration? All right, so if it's a constant acceleration, we know we got to use one of these 3 equations. Or a combination of one, or a combination of more than one. But we have to use those equations for constant acceleration. So the way to do this is you look at what you have initially, what you have finally. So this is the initial velocity here. This is the final velocity, we're just calling v here. And we have the distance that it travels. So I look over here, this one has time. We don't have time. We don't have time in here. But we do have the distance. We have the 2 velocities. We could solve this for the acceleration. So I'm going to use this equation here. I always write down the equation you're going to use first before you start to solve it. And don't put in numbers right away. Figure out what you're going to solve for. I want to solve this for a, so I'm going to do my algebra first without putting any numbers and get an a equals something before I start putting the numbers in. So first I'm just going to subtract v naught squared from both sides. So I'm going to get v squared minus v naught squared is equal to 2a x minus x naught. Well, my initial position, we're going to call this 0. So this is just going to be 0. That's going to go away. So to get a by itself, I'm just going to have to divide by 2 and divide by x. Divide both sides by 2 and x. So when I solve this, I'm going to get a is equal to v squared minus v naught squared over 2x. Now I have my equation where I have the variable I want to solve for, and I have everything on this side that I know. Then I can solve it. So I'm just going to plug in the numbers. So a is equal to, now v squared is 400 squared minus 300 squared, all over 2 times the distance. Now you got to be careful, this is in kilometers. We always have to do everything in meters so that it matches. So I'm going to convert that. Well, it's easy, that's 4,000 meters. And then, when I do that, I plug all that into my equation. Number 13, and I get that that the acceleration is 8.75 meters per second squared. Now, it's not part of the question, but I also want to know, how long did it take that acceleration? How much time occurred? Well, this is easy. Now that I know the acceleration, I can go back to this equation and say, oh, I know the initial, I know the final, I know the acceleration, I can solve this for time. So I'm going to do that. I could do it for this one too, because I know everything here except time. This one's easier because time is squared up here. To get time, you'd have to solve a quadratic. So I'm going to use this equation here. So let me do it over here. V equals v naught plus at. I'm going to solve this for t, so I'm going to move this over here. So v minus v naught is equal to at. And I'm going to divide by a, and so I get v minus v naught over a is equal to t, or t is equal to 400 minus 300 over 8.75. And when I do that, I get the amount of time it takes for the jet to accelerate is 11.4 seconds. So jets, which are going very fast, can go 4 kilometers in 11 seconds while it's accelerating the whole time. And that's how you do that kind of problem. So that was number 14.